Hello, in this lecture we'll discuss about the basics of inheritance and we'll come back on some things that you already saw in previous lectures. So first of all, the goal of this lecture is to discuss what is exactly inheritance, when to use it, and by the way, notice that in Pharo, we have exactly the same inheritance model as in Java. So, inheritance, basically this is a reuse mechanism. So, it comes from the fact that we don't want to re-implement all the code that already exists. And usually code exists in classes. So it means that we don't want to customize it, extend it, but we don't want to re-implement it. So sometimes we want to specialize it and we want to express a delta in subclasses. So what we want, this is to adapt existing code by extending the behavior and the state in existing classes. And we don't want to re-implement everything. And the solution for that, this is class inheritance. Okay, so we need to extend existing definition of classes in subclasses. So let's take an example. What we can do when we create a new class. So here I create a new class, a colored rectangle. This is a subclass of rectangle. And what can I do in a subclass? I can add state, I can add behavior, and I can use superclass behavior and state, and I can redefine superclass behavior to specialize it. So let's start with the hierarchy. So if I look at the hierarchy of classes, the root of the hierarchy is usually the object class. So all classes eventually inherit from objects, and the object class defines the common behavior of all objects. It raises errors when we send a message that is not understood. It provides some accessor to access the class of an object, etc. In Pharo, there is a subtle differences here from other languages. We have the proto-object class, which is a superclass of objects, and it has a special purpose. This is not really important for the comprehension of all the object model. This is just a little difference in the Pharo language. It raises as much error as possible, and it allows for building advanced techniques and advanced tools such as proxy objects and things like that. In the following of the lecture, we'll just use the object class. So if we look at inheritance, there are two aspects of inheritance. The first one is the static aspect for instance variables. During the class creation, I can compute all the instance variables of a class. And then there is the dynamic aspect for behavior. During the execution, I can send messages to objects, and here I will dynamically select the method to execute. Let's have a closer look to these two aspects. First, when I define the color rectangle subclass here, I can see that this color rectangle class has 4 instance variables. 2 of them are defined directly in the color rectangle classes, and 2 of them are defined in the superclass. And in fact, the instance variables are computed by the union of all instance variables in the hierarchy chain. And usually there is no duplicate in the chain. Otherwise, I will have shadowing in the name of instance variable. For behavior, when I send a message, so here I have an object, a colored rectangle. It is an instance of the colored rectangle class. If I send a message to this object, for example, I send the rear message, so it means that the system will first look in the class of the receiver. So you already saw that in the colored rectangle class. It will check if the rear message exists, and if it does not, it will continue in the superclass, and then it will find it here in the rectangle class. So this is why we said that the inheritance of behavior is dynamic. So what you should know in this lecture, what are the key messages, is that inheritance allows developer to add state and behavior and to refine behavior in subclasses. Usually a class has only one superclass. This is a single inheritance model. And all classes of the system eventually inherit from objects that provide the basic behavior for all objects in the system. Inheritance of state is static, as we saw. The instance variable is computed from all instance variables defined in the hierarchy of class. And the inheritance of behavior is dynamic.